Uh, okay. So, Hitesh sir, uh, please stop your presentation just for a while so I can introduce you.
Okay.
Okay. So, good morning, everyone. This is Tejas Fias, Assistant Professor from the Parul University Mechanical Department. Today, we have organized a webinar on IC engine emissions and its future. Okay. Our today's expert is Dr. Solanki, PhD in combustion chamber from Shanghai University. Widely national number of papers, approximately 18 papers at various national international journals and conferences. One patent is also registered. Working as an assistant government. If you have any query, any question, any of these two numbers, this is my number and Rakesh Prajapati sir's number. So you can contact me, you can WhatsApp me directly over time. I would like to hand over the session to Hitesh sir. Sir, you can begin now.
Okay. Thank you.
Yeah.
So directly jump to the presentation. Already my introduction was given by Vyas sir, and you also know the title, that is the IC engine emissions and its future. The screen is visible, na sir?
No, sir, it's not visible right now.
It's not visible. Wait, yes, I again start sharing. Now it is visible.
Yes, sir, it is visible.
Okay. My topic is running by these many contents, that first we are get a little idea about what is emission or pollution, then what are the type of pollution, then if pollution is done, what are the hazards is going on, then we are then narrow our session by impact of air pollution only, then what is emission and the Bharat stage norms, because in India we are always talking about BS4, BS6 car is running or vehicle is running, right? And how control system already implemented in the vehicles, and what are the inventions going around to reduce emission as well as the other technologies also. So start with what is emission and the pollution. Can anybody tell me that what emission for there? Anyone? Just reply. What is meaning of
Uh,
emission or
sir,
pollution?
sir, it is sir, it is live presentation, so only there is
Okay.
only one communication.
Okay. So the uh,
Okay.
emission have so many definitions. So I write a few definitions only. So as per my or very straight in the nature, things which is not desirable for in the emission or a pollution. Suppose we are taking as example of our body. Suppose we are going to eat so many sugar content, then chances of sugar is high. So our body is also not expecting the higher amount of things. So same as the nature also, it is also not allow a higher amount of things. So which is not desirable to other person, that is considered as a emission or pollution. But in technicality, the pollution refers to any substance that negatively impact the environments or organisms that live within the affected environments. Again, that pollution is when gases, smoke or chemicals are introduced into the environment in large doses. Large doses is the main content, because uh, all our knows that कि हमने इतना कर दिया तो क्या फर्क पड़ेगा, लेकिन आई एम टॉकिंग अबाउट द लार्ज कंटेंट. तो करना चालू किया, आप बूंद बूंद वेस्ट करना चालू कर लोगे, लेकिन अगर हम हमारी पूरी पॉपुलेशन को काउंट करेंगे और वो भी सारा बूंद बूंद पानी वेस्ट करना चालू करेंगे, तो दैट इज आल्सो नॉट गुड. दैट्स व्हाई द वर्ड इज यूज लार्ज डोजेस, that makes it harmful for human, animals and the plants, right? And some of the pollutions can be seen, some we cannot see. Again, another word, the acting of making the air, water, etc. dirty and dangerous. It is also considered as a pollution. Another that pollution is the introduction of harmful materials into the environment. The all four definitions have the same meaning, but different contents is introduced. Now, what type of pollutions are there? Pollutions are air pollutions, water pollution, soil pollution or contamination, light pollution, radioactive contamination, and then visual pollution and over seen this figure, that is example of the acid rain. This is an example of the ozone layer depletion, and this is an example of the global warming. These all three are major concern for a human being. What is impact of air pollution? Mainly human body. So major, it is impact our health. A very famous case in the Delhi that they are start odd even combination reduce the air pollution. This figure have two sides. This is a clean atmosphere. This is a polluted atmosphere. Atmosphere. They are try to reduce and running on the road. So, that is one concept used by the Delhi, right? Now,
Hello friends.
this is this video is basically talking about the Bharat stage norms. But what is norms? So, if you seen that different pollution, that is said the large doses. So, what Bharat stage norms do? They are classify or they are provide a limit emission. If your vehicle is emitting a higher emission that level, then you are not able to certificates, right? So what is the limit is set for Bharat 6, that also explained in this particular video. So we have going to see these videos.
Hello friends. Welcome to Mathematic YouTube channel नोम्स। तो सबसे पहले हमें एमिशन नोम्स क्यों लाना पड़ा। एमिशन नोम्स यानी कि जो उसमें से जो पॉल्यूशन निकलता है उसको हम एमिशन बोलते हैं, और उसको एमिशन को कंट्रोल करने के लिए जो नोम्स बनाया है दैट इज कॉल्ड द एमिशन नोम्स। तो फ्रेंड्स यहाँ पे मैंने फिगर बता के आपको समझाने का ट्राई किया है कि दिल्ली जो है, दिल्ली में जो ट्रैफिक लगता है, ठीक है, 40,000 लीटर्स ऑफ फ्यूल पर डे। ट्रैफिक जाम में 40,000 लीटर दिल्ली वाले उड़ा देते हैं, ठीक है, विच इज नियर बाय 40,000 kg ऑफ डीजल, पेट्रोल एंड सीएनजी। ओके, और उससे जो 15,609 kg। ओके, तो ये थोड़ा पुराना डेटा है, लेकिन अभी तो इससे भी बढ़ गया होगा। So, अभी जो ट्रैफिक की समस्या हो रही है, ठीक है, पहले तो क्या था, शुरुआत में जब गाड़ियां बनी थी तब ये पॉल्यूशन का इश्यू नहीं था, लेकिन जैसे जैसे गाड़ियां बनती गई वैसे वैसे पॉल्यूशन का इश्यू रेज होता गया, ठीक है। इसीलिए हम सो बेसिकली जो एमिशन नॉर्म्स आया वो हमने यूरोप कंट्री से लिया है, इसीलिए हमने यूरो नॉर्म्स एज अ रेफरेंस लिया है, ठीक है। तो यूरो नॉर्म्स क्या है? तो यूरो नॉर्म्स डिफाइन द मैक्सिमम लिमिट ऑफ पॉल्यूटेंट दैट द व्हीकल कैन हैव, मतलब ऑक्साइड, सल्फर एंड सस्पेंडेड पार्टिकुलेट मैटर यानी कि पीएम। तो पार्टिकुलेट मैटर ये जो है उसको एक लिमिट कर दी गई है, ठीक है। सो इफ द व्हीकल एमिट मोर देन दिस लिमिट इट कैन नॉट बी सोल्ड इन यूरोप, मतलब कि अगर वो लिमिट से ऊपर व्हीकल का एमिशन करता है तो वो बिकने को नहीं बेच सकते, ठीक है। द यूरो लेवल ऑफ भारत स्टेज नॉर्म्स, ठीक है। एंड हमने शुरुआत में जो मेगा सिटी बाद कंट्रोल द एमिशन, मतलब कि जो एमिशन को एफर्ट 90 नॉर्म्स यहाँ पे फोर्सफुली थोड़ा अप्लाई किया गया। देन 1995 जो है उसमें जो गवर्नमेंट ने कैटालिटिक कन्वर्टर और ये सब उन्होंने मेट्रो सिटीज है यहाँ पे दिल्ली, कलकत्ता, मुंबई, चेन्नई, ठीक है, वहाँ पे ये सब 42 मेजर सिटीज है। ओके, और आज जो है वो अवेलेबल अक्रॉस द कंट्री, पूरी कंट्री में वो अप्लाई किया गया है कैटालिटिक कन्वर्टर। उसके बाद जो 2000 है उसमें हमने BS1 अप्लाई किया, ठीक है, 2000 पैसेंजर कार कॉमर्शियल व्हीकल यूरो 1 इक्विवेलेंट इंडिया 2000 नोम, ठीक है, वो हमने अप्लाई किया। और वो जो था सीधा नेशन वाइड हमने यूज़ किया है। और यहाँ पे जो 2001 है, ठीक है, 2001 में हमने यूरो 2 यानी कि BS2 नॉर्म्स अप्लाई किए। और 2001 में जैसे फ्रेंड्स यहाँ पे और बुक में थोड़ा डेटा मतलब दिल्ली, मुंबई, कोलकाता एंड चेन्नई, ठीक है, तो यहाँ पे लागू हुआ 2001 में यूरो 2 यानी कि भारत स्टेज BS2, ठीक है। अब 2003 एंड 2005 एज पर दी मेट्रो सिटी में बहुत सारी सिटी में जैसे कि अहमदाबाद, पुणे, सूरत, कानपुर, आगरा, बहुत सारी सिटी में 2003 में वो BS2 हमने अप्लाई किया। और 2005 में हमने नेशन वाइड BS2 अप्लाई किया, ठीक है। उसके बाद बारी आती है भारत स्टेज 2 यानी 2005 में, यहाँ पे फ्रेंड्स वो लिखा नहीं है लेकिन वो सब अंदर मिक्स है। 2005 में मैं बोल रहा हूँ, आप शांति से सुनना। 2005 में भारत स्टेज जो 3 है, ठीक है, वो दिल्ली, मुंबई, कोलकाता, चेन्नई, ये अहमदाबाद, पुणे, सूरत, ये बड़ी बड़ी सिटी में 2005 में यूरो 3 अप्लाई हुआ, ठीक है। और 2000 नेशन वाइड मतलब कि पूरे भारत में यूरो 3 या तो BS3 2010 में अप्लाई हुआ। मैं फिर से रिपीट कर रहा हूँ, पूरे भारत में 2010 में BS3 अप्लाई। लेकिन 2010 में वो 13 मेट्रो सिटी में ही लागू हुआ था, जैसे कि दिल्ली, मुंबई, कोलकाता, चेन्नई, बैंगलोर, हैदराबाद, अहमदाबाद, पुणे, सूरत, कानपुर। 10 4 जो है जो BS4 जो आया 2017 में, 2017 में अक्रॉस द इंडिया BS4 अप्लाई होगा, ठीक है। अब पॉल्यूशन इतना बढ़ गया है, इतना बढ़ गया है कि जो BS5 हमने स्किप कर दिया है और सीधा BS6 पे हमने जंप करी। यहाँ पे जैसे मैंने फिर से बताने का ट्राई किया है, BS2 जो है यूरो 2 वो हुआ अप्रैल 2005। जो 3 है वो ये पूरे मतलब नेशन वाइड है। BS3 जो है वो अप्लाई हुआ 1 अप्रैल 2010 एंड BS4 जो है वो हुआ 2012, ठीक है। और जो 17 में जो 5 है वो हमने स्किप करके सीधा अब 20 में हमने BS6 पे जंप लगा दिया, ठीक है। तो इस तरह से एमिशन नॉर्म्स जो पॉलिसी बनी, ठीक है, वो ईयर वाइज अप्लाई पढ़ोगे तो बहुत इजीली समझ में आ जाएगा। लेकिन जब पेट्रोल और डीजल एमिशन नॉर्म्स में क्या जो एमिशन होता है वो होता है कार्बन मोनोक्साइड, हाइड्रोकार्बन, नाइट्रोजन ऑक्साइड एंड पार्टिकुलेट मैटर, ठीक है। तो यहाँ पे आप देख सकते हो ये BS3, BS4 एंड BS6 का दिया है यहाँ पे। तो कार्बन मोनोक्साइड जो है वो BS3 में इतना अलाउ हो रहा था 2.3, ठीक है, और यहाँ पे 1 और यहाँ पे 1। वैसे हाइड्रोकार्बन जो है वो पहले 0.20 अलाउ नाइट्रोजन ऑक्साइड जो है वो पहले 0.5। तो ये फ्रेंड्स जो लिमिटेशंस थी एमिशन की वो हमने बहुत ने जो रेगुलेशन बनाए उसमें एमिशन जो है गया है। बहुत सारी कंपनियों को प्रॉब्लम भी हो रहा है, उनको ज़्यादा से ज़्यादा रिसर्च करना पड़ रहा है और अब हम इलेक्ट्रिक व्हीकल की ओर भी जा रहे हैं। ठीक है, सो बेसिकली आप यहाँ पे देख सकते हो जनरली जो हाइड्रोकार्बन है वो है एंड जो नाइट्रोजन ऑक्साइड है जाता है। ठीक है, ऑक्साइड है यहाँ पे 0.50 था और यहाँ पे जो है वो सेम है वो सही था। नो, ठीक है, ये जो पॉल्यूटेंट्स है ठीक है कंट्रोल किया, यानी आप कोई ना कोई टेक्नोलॉजी ऐसी यूज करो कि जिससे कि कार्बन मोनोऑक्साइड हाइड्रोकार्बन नाइट्रोजन ऑक्साइड कम से कम प्रोड्यूस हो। ठीक है, बेसिकली इसका मीनिंग यही है। ओके, तो यहाँ पे भी एक दिया है पर्टिकुलर मैटर के लिए ग्राम पर किलोवाट आवर, यानी कि जो स्टेशनरी इंजन है वो 1 किलोवाट आवर में कितना पर्टिकुलर मैटर को निकाल सकते हैं। ठीक है, तो BS1 में वो इतना था 0.4, BS2 में वो जनरली 0.15, BS3 एंड BS4 आप देख सकते हो यहाँ से 80% उसको रिडक्शन किया है एमिशन में। ठीक है, तो अभी जो भी गाड़ियाँ जो बिक रही है वो ये फुलफिल करना जरूरी है। ठीक है, सो फ्रेंड्स नॉर्म्स के बारे में छोटा सा इंट्रोडक्शन। अगर आपको ये वीडियो अच्छा लगा
Now we already seen that government give us target. If I'm talking directly, that they are making the norms. Okay, this much emission is allowed. It. Now you do research the emission anyhow. So that's why so many companies raising that question that we are going to do that. But government said that you have to do it, means you have to do it. And now what companies are doing, how they are controlling emissions. So for how they are doing that control emission, but for that or before that, we have to know from which area the emissions was done. So normally we assume that the emission done, but it is not a true, or that is only not one source to emit the emission. There have so many other means employed to limit noxious combustion component, means component are that is a silencer, the crankcase, that is the upper area and the lower area of the engine. Engine have uh, below the cylinder area and above the cylinder area, and the fuel tank and the carburetor. Now, how that fuel tank is generate emission? So fuel tank generate emission because we know that a fuel, if we kept a fuel open to atmosphere, it will uh, evaporated. So during that evaporation, some amount of hydrocarbon was generated. That's why this is also considered as a emission side. A carburetor, how that carburetor is considered in emission side? Same, uh, fuel was evaporated from the carburetor side also. That's why that is also considered in the emission side. So what are they doing? What they are doing? That exhaust pipe discharge burns and unburned hydrocarbons, carbon monoxide, oxides of nitrogen and sulfur, and the traces of various acids, alcohols and phenols. These things are getting out from the exhaust pipe. What emission in the crankcase? The crankcase is a secondary source of unburned hydrocarbons, and to lesser extent carbon monoxide also emitted. What about in fuel tanks? In fuel tanks, This problem is arising in the older automobiles engine, and carburetor also generates some hydrocarbons that are continuously evaporating from the gasoline, consist a minor but not insignificant contribution factor in the pollution. Now, uh, what are that emissions are generated and how that emissions are controlled by implementing a different advancements that we have seen by 20 minutes video I have. We discuss about that which emission is there and how they are controlling and how it is generating. So see this video very
This section
carefully.
examines sources of emission from light vehicles. A light vehicle during normal use. Emission control systems are designed to limit the pollution caused by the harmful products of storing and burning fuel. Emissions from a petrol-driven motor vehicle usually come from four sources: the fuel tank, the carburetor, the crankcase, and the system. Allow the atmosphere. These are called evaporative emissions. The crankcase and exhaust system emit pollutants directly from the engine into the atmosphere. They are caused when hydrocarbons, lead compounds, and oxygen and nitrogen from the air are burned in the combustion chamber. In a compression ignition engine, emissions originate from the engine and escape to the atmosphere from the exhaust and the crankcase breather. This section examines evaporation emission control systems. Early vehicles vented the fuel tank through the filler. Some of the fuel in the tank would vaporize. Some vapors escaped from the filler cap, some from the carburetor. Non-vented filler caps are designed to stop the exit of vapors. A vacuum relief valve can relieve low pressure in the tank when the temperature drops. This will also stop the tank from collapsing if its internal pressure falls below atmospheric pressure. The fuel cap may also incorporate a pressure relief valve. If the tank's internal pressure exceeds the set value of the relief valve, it can stop the tank from rupturing. Some modern caps have no valves at all and are completely sealed to stop the entry of air and water, as well as the emission of fuel vapor. Modern tanks also contain an expansion volume either directly in the shape of the tank or in a separate chamber connected to the fuel tank by tubing. A liquid vapor separator may be connected to the tank by a number of tubes. This separator allows liquid fuel to separate from the vapors and return to the tank. A vapor line is connected to the vapor space in the tank, or the liquid vapor separator. It carries fuel vapors from the tank to a storage volume. This vapor line can incorporate check valves. If the vehicle is tilted too far from the horizontal, they stop liquid fuel entering the storage volume. A storage device is used to store the fuel vapors. The fuel tank breathes through this storage device. Some vehicles use the engine crankcase. When the temperature of the fuel in the tank increases, fuel vapors are forced along the vent line, past the liquid check valve, and into the crankcase. When the engine starts, the positive crankcase ventilation system flushes vapors out of the crankcase and into the intake manifold, where it joins with the inlet air-fuel mixture. Once in the inlet manifold, the vapors are drawn into the engine, where combustion can convert them into carbon dioxide and water vapor. This section: petrol, diesel, LP, and natural gas are all hydrocarbon compounds. Hydrocarbon emissions react with other compounds in the atmosphere to produce photochemical smog. Hydrocarbons are a major source of motor vehicle emissions. Petrol needs to evaporate easily to burn properly in an internal combustion engine. But this property also means it evaporates easily into the atmosphere at ordinary temperatures and pressures. When a vehicle is being refueled, hydrocarbon vapors can escape from the filler neck into the atmosphere. When the vehicle is left in the sun, its temperature increases and fuel evaporates from the tank, and if there is a carburetor, from it as well. An evaporation control system is fitted to modern vehicles to collect and from the tank and the carburetor. Then, when conditions are and burned as part of the combustion process. In a petrol engine vehicle, during an engine cycle, some of the gases escape past the piston rings into the crankcase. This is called blow-by. Some of these blow-by gases mix with heated vaporized oil and can usually escape out into the atmosphere. Modern vehicles direct these gases and vapors back to the system to be burned during normal combustion. Hydrocarbons can also be part of the exhaust gases. During the center, some intake charge cooler posture. Air with these cooler parts, and they cool down, too low for combustion to occur. And when the exhaust port opens, they and fuel port mix fuel for the quantity of air. Combustion will be incomplete, and fuel will leak. If an excessively lean mixture is used, then combustion takes longer, and the flame may extinguish before it is complete. When the exhaust port opens, unburned hydrocarbons will be exhausted from the cylinder. This section examines carbon monoxide. The monoxide gas, telling it lethal or carbon is reduced oxygen molecules. This can be caused by an incorrect air-fuel ratio. In monoxide, treating the exhaust gas. Carbon with fuel. It isn't poisonous, but many scientists monoxide to carbon dioxide. Carbon dioxide and LPG fuel vehicles. If the exhaust gas is hot enough, hydrocarbon can be completed by adding extra air or manifold. This afterburning produces water and carbon dioxide, which are then exhausted to the atmosphere. The pulse air method uses the pulse to open and close a reed valve. It admits air into the exhaust manifold. Air is the exhaust manifold. This method suits engines with 4 cylinders or less, because their exhaust pulsations are further apart. Larger capacity to supply a larger volume of air. The pump is normally driven by a V-belt and four ports. The pump. Electronic fuel injection and engine management systems deal with emissions more effectively than carbureted engines by more fuel ratio entering each cylinder and by ensuring the ignition timing matches operating conditions. Sensors around the engine send the ECU information about airflow, coolant temperature, throttle position, and engine speed. The ECU uses this to set fuel and ignition settings from its programmed memory. Most systems also use the amount of action is being completed, which in turn mixture entering the engine. A voltage signal is then relayed back to the control unit to indicate whether the mixture is rich or lean. More oxygen indicates a lean mixture. Less indicates a rich mixture. The control unit then adjusts the amount of fuel being injected into the engine to keep the air-fuel ratio very close to the chemically correct composition for complete combustion. By mass, this is 14.7 of fuel, known as the stoichiometric ratio. This section examines combustion control. Approximately from to the combustion modern vehicles use a combination. Carburetors meet emission standards by maintaining To achieve this, most carburetors require an air supply at constant temperature. A heated air inlet system uses the control system uses a temperature-sensitive valve inside the air cleaner. It operates a flap that blends the hot air with cool air. It receives air at about 40 degrees Celsius, regardless of outside air temperature. Maintenance of this temperature assists vaporization of the fuel, particularly when the engine is cold. Vaporization is also assisted by heating the intake manifold, normally by circulating hot liquid coolant through passages in the manifold. If a manifold is too cold, fuel condenses on its inner surfaces, which will create a lean mixture and may cause incomplete combustion. Carbon monoxide and hydrocarbon emissions are highest from a cold engine. Changes in operating conditions can change mixture conditions within the manifold. If a carburetor at speed and the throttle is suddenly closed, any fuel condensed on the manifold walls is drawn into the low pressure in the manifold also acts on the idle circuit in the carburetor to cause a larger amount of fuel to flow from the idle discharge port. All of these factors enrich the mixture entering the engine. There is only a relatively small quantity of mixture in the combustion chamber at this point, so turbulence tends to be poor. This can lead to incomplete combustion and the release of unburned gases into the exhaust. The throttle positioner and dashpot slow down the rate of closure of the throttle plate. This allows more time for air to enter the manifold and for the fuel to be completely closed. A more combustible mixture is thus formed, which leads to complete combustion and a reduction in hydrocarbon and carbon monoxide emissions. combustion chamber design can affect the combustion process also, and therefore the level of emissions. Designs that increase gasization distribute the fuel more evenly in the combustion chamber. Quenching of the combustion zones in the combustion chamber where surface temperature, the flame temperature drops so low in these areas that the flame goes out or is quenched. Fuel left unburned in these zones as hydrocarbon and carbon monoxide emissions. If the spark plug is positioned so that the flame front travels evenly through the combustion chamber, combustion is more complete. Gas flow rate and volumetric improved by using 2 intake valves in each cylinder. The effective port opening is increased and the gas flow rate increases. Changing valve timing also alters the combustion process. Reducing valve overlap reduces the scavenging effect. It also reduces hydrocarbon emission. Maintaining the stoichiometric ratio within close limits is necessary for the system. It receives all of the exhaust gases, treats substance. This is done by a catalyst in the converter. A catalyst causes a chemical reaction, but after the reaction ends, remains unchanged itself. The catalytic converter has a ceramic core housed in a stainless. The core contains many small passages through which the exhaust gases pass. A thin coating of aluminium oxide called alumina wash coat covers these inside passages. It has a rough surface, and it's there to provide. The catalyst is finely dispersed over the surface of the alumina wash coat. The large surface area ensures that virtually all of the exhaust gases come into contact with the catalyst as they pass through the passages in the core. Leaded fuel cannot be used in vehicles with a catalytic converter. The lead contaminates the catalyst and stops the reactions from occurring. The use of unleaded fuel has a further benefit of reducing the amount of lead emitted into the atmosphere. Diesel engines are usually low in carbon monoxide and hydrocarbon emissions, though some do emit high levels of the oxides of nitrogen. The main problem with diesel engines is the emission of particulates, minute particles of carbon, visible as black smoke. Most diesel engines are electrically controlled injectors. This has reduced considerably the emission of particulates and oxides of nitrogen. This section examines oxides of nitrogen. Air that's drawn from the atmosphere into an engine contains almost 80% nitrogen. Under the high temperatures and pressure of combustion, this nitrogen combines with oxygen to produce oxides of nitrogen. Almost all internal combustion engine exhaust gases contain these chemicals. They are more likely to be produced when high peak temperatures occur during combustion. If a lean mixture is used, formation of hydrocarbons and carbon monoxide is reduced. But for oxides of nitrogen, it is increased. This is due to the high temperature. Oxides of nitrogen are claimed to be major contributors to photochemical smog. Compression ignition engines can produce high levels of oxides of nitrogen. Oxides of nitrogen irritate the eyes, nose, and throat. In extreme cases, coughing and lung damage can occur. If valve overlap is maintained or even increased, oxides of nitrogen can be reduced by an exhaust gas recirculation or EGR valve connected between the exhaust port or manifold and the intake system. If engine conditions are likely to produce oxides of nitrogen, the EGR valve opens, letting some gases pass from the exhaust into the intake system. During combustion, these exhaust gases absorb heat from the burning air and fuel. This reduces the formation of the oxides of nitrogen. The EGR, the engine is using a lean mixture. When the engine first starts and until it warms up, a temperature manifold pressure reaching the EGR valve and stops it from operating. Manifold pressure reaches the valve when the engine is warm and when the EGR port, the carburetor, is influenced by the position of the throttle. This is generally at light throttle openings, when a lean mixture could cause increased oxides of nitrogen. It does not operate at idle or at wide open throttle. Oxides of nitrogen can also be reduced by retarding ignition timing. This lowers the maximum temperature reached during combustion. The maximum ignition advance setting is then said to be emission limited. However, it also lowers engine output and increases fuel consumption. Spark control systems use ignition timing to optimize engine output and fuel consumption with minimal emissions. They control vacuum levels to the vacuum advance unit on the distributor. In some designs, vacuum signals are delayed with vacuum valves in the signal line. In other designs, the vacuum signals are sustained. Units on some distributors. The degree of control needed depends on many other factors, and each application should be considered individually. This section examines particulates. Particulates from modern engines are usually carbon-based. Older vehicles may produce lead-based particulates. This is caused by lead compounds used in the fuel to raise its octane rating. In spark ignition engines, particulates are caused by incomplete combustion of rich air fuel mixtures. In compression ignition engines, they're caused by a lack of turbulence and lack of oxygen. Section examines crankcase emission control. While the engine is running, some gases from combustion in the case. This leakage is called blow-by. Unburned fuel and water from condensation also find their way into the crankcase and some. When the engine reaches its full operating temperature, the water and fuel evaporate. To prevent pressure buildup, the crankcase must be ventilated. In older vehicles, crankcase vapors were vented directly to the atmosphere through a breather tube or road draft tube. It was shaped to help draw the vapors from the crankcase as the vehicle was being driven. Modern vehicles are required to direct crankcase breather gases and vapors back into. A common method of doing this is called positive crankcase ventilation, or PCV. A valve called regulates gas case and the inlet manifold. It is controlled by the pressure in the manifold. The valve is closed and air cannot enter the inlet manifold. This allows the engine to start. At idle, low pressure in the manifold draws the valve to the other end of the body. This lets a small, measured amount of vapor pass the valve. At wider throttle openings, the valve plunger position allows maximum flow through the body, which gives maximum crankcase ventilation. The system air than just blow by, so there's a fresh air intake, usually at the air cleaner, to direct filtered air to the crankcase. Far openings produce maximum blow by. Can't be handled through the vacuum system, are directed back through the inlet connection to the air cleaner, where they join the carburetor intake air and are drawn into the cylinders for burning. Another kind of storage is charcoal. Activated means the charcoal is porous with a large surface area. It can store large quantities of fuel vapor. It has connections for the fuel tank vent line and the purge line, which carries the vapors to the intake manifold. In some designs on carbureted engines, it also has a connection from the carburetor bowl. When the engine is running, the action of the piston during the intake strokes creates a low pressure area in the inlet manifold. This can be used to open a purge valve, which draws fresh air into the bottom of the canister. The air directed to converters. The purge valve is designed to operate only at speeds well above idle. If it operated at low speeds, the extra fuel vapors could upset the air-fuel mixture, which could cause poor idling and rough running. The evaporation of automotive fuel is a major source of hydrocarbon emissions. The rates of evaporation are higher with petrol than diesel because petrol is more volatile.
So this is something about the emissions and it's how it is controlled system implemented by the companies of different automobiles. Now, inventions running around the world. All the engines we have uh, uh, noted over here, hydrogen vehicles, electric vehicles, solar vehicles, hybrid vehicles, fuel cell driven vehicles, and air driven vehicles. But can we call a few of these engines or few of these vehicles are IC engine vehicles? That is a big question mark because IC engines is considered as a combustion chamber, but a few vehicles are doesn't have the combustion chamber because the many of the vehicles which is listed over here are used electric power to run the engine. Suppose we are talking about the hydrogen vehicle. So in these vehicles, it is a combustion engine we can say because the hydrogen is burned in the presence of oxygen and we are able to get the output power. But electrical vehicles, there is nothing like combustion chamber present in it. That all the wheels are connected with the motor. The motor will get the electricity from the stored battery, and the vehicle will move. Solar vehicle, again the concept is same. In this kind of vehicles, solar vehicles, they store energy generated by the solar plates in the battery, and that power is given to the motor and the vehicle was moved. Hybrid vehicles are run on the concept of the IC engine as well as the electric vehicles. So when there is a discharge of our electricity batteries, it is run on the regular fuel and or we can say the fossil fuel, and when the the battery is charged, it is again run on the uh, electricity. Fuel cell driven vehicles are also come in the category of the electric vehicle. Now, air driven vehicle is little bit a different concept. What is running over here? Over here, we are use a high compressed air. Then it is insert in that in cylinder top, and piston movement is controlled by a high pressure air only. So again over here we don't have any sort of IC engine. So uh, out of these six, maybe one and two vehicles are considered in the category of the IC engines, but another other vehicles are not considered in as a IC engines. But still we are called as a IC engines. Now another question: can electric vehicles or a vehicle run on electricity are less pollutant? Many of the person said yes, it is a less pollution because we are not able to get any smoke which is coming out from the silencer. But a bigger question: from where electricity is generated, right? So for this understanding of this concept of electric vehicle are say eco-friendly or not, we have another very short video. So they will maybe change your mind.
Do electric cars really help the environment? President Obama thinks so. So does Leonardo DiCaprio and many others. The argument goes like this. Regular cars run on gasoline, a fossil fuel that pumps CO2 straight out of the tailpipe and into the atmosphere. Electric cars run on electricity. They don't burn any gasoline at all. No gas, no CO2. In fact, electric cars are often advertised as creating zero emissions. But do they really? Let's take a closer look. First, there's the energy needed to produce the car. More than a third of the lifetime carbon dioxide emissions from an electric car comes from the energy used to make the car itself, especially the battery. The mining of lithium, for instance, is not a green activity. When an electric car rolls off the production line, it's already been responsible for more than 25,000 pounds of carbon dioxide emissions. The amount for making a conventional car, just 16,000 pounds. But that's not the end of the CO2 emissions, because while it's true that electric cars don't run on gasoline, they do run on electricity, which in the US is often produced by another fossil fuel, coal. As green venture capitalist Vinod Khosla likes to point out, electric cars are coal-powered cars. The most popular electric car, the Nissan Leaf, over a 90,000-mile lifetime, will emit 31 metric tons of CO2 based on emissions from its production, its electricity consumption, an average US fuel mix, and its ultimate scrapping. A comparable Mercedes CDI A160 over a similar lifetime will emit just 3 tons more across its production, diesel consumption, and ultimate scrapping. The results are similar for a top-line Tesla, the king of electric cars. It emits about 44 tons, which is only 5 tons less than a similar Audi A7 Quattro. So throughout the full life of an electric car, it will emit just 3 to 5 tons less CO2. In Europe, on its European trading system, it currently costs $7 to cut 1 ton of CO2. So the entire climate benefit of an electric car is about $35. Yet the US federal government essentially provides electric car buyers with a subsidy of up to $7,500. Paying $7,500 for something you could get for $35 is a very poor deal. And that doesn't include the billions more in federal and state grants, loans, and tax write-offs that go directly to battery and electric car makers. The other main benefit from electric cars is supposed to be lower pollution. But remember Vinod Khosla's observation, electric cars are coal-powered cars. Yes, it might be powered by coal, proponents will say, but unlike the regular car, coal plant emissions are far away from city centers, where most people live and where damage from air pollution is greatest. However, new research in the proceedings of the National Academy of Sciences found that while gasoline cars pollute closer to home, coal-fired power actually pollutes more, a lot more. How much more? Well, the researchers estimate that if the US has 10% more gasoline cars in 2020, 870 more people will die each year from the additional air pollution. If the US has 10% more electric vehicles powered on the average US electricity mix, 1,617 more people will die every year from the extra pollution. twice as many. But of course, electricity from renewables like solar and wind creates electric cars without CO2. Won't the perceived rapid ramp up of these renewables make future electric cars much cleaner? The US gets 14% of its electric power from renewables. The Energy Information Administration will have gone up just 3%. 17 fossil fuels that generate 65% of US electricity today will still generate about 64% of it in 2040. While electric car owners may cruise around feeling virtuous, the reality is that the electric car CO2 costs taxpayers a fortune and surprisingly generates more air pollution than traditional gasoline cars. I'm Bjorn Lomborg, president of the Copenhagen Consensus Center.
How electric are safe or not, right? Or so can say that the analysis is also required for actually reducing. This is what a nutshell video regarding what we have learned in this particular maybe 1 hour session. But before that, question is if or we can give something to the atmosphere. So my answer is yes. We that is also generating a pollution. But can we maintain that pollution level which is generated by our vehicle? So answer is yes. So how? So first we regular do the services of our vehicles. Services, it means regularly we go for a change. We clean our silencer. We check air pressure of our vehicle tire and do not drive our vehicle within or outside the certain limits. Certain limits, it means it is already highway. The average speed is this much, so you have to on. And then two wheel between. So it means if we are traveling as a way, contribute reduce in the emission level, right? Only for the this is obviously it is not for India, but it is said a reality.
We talked about vehicle emissions earlier. Experts have identified diesel cars as being partly responsible for the worsening air quality and increasing level. Korea has been turning to eco-friendly vehicles, rolling out various benefits for those who drive these green cars.
When autos cars popular among Koreans than cars with gasoline and economy and stronger horsepower drive. In addition, in sunlight, the nitrogen oxide in the car emissions breaks down into atoms through a photo. Ozone at the ground level presents intractable air quality and health problems.
Breathing ground-level ozone can be extremely damaging to one's skin, eyes, and respiratory system. According to the 2006 guidelines of the World Health Organization, when the ozone level is above 90 ppb at ground level, even in 1 to 2%.
These emissions test
Huh?
on diesel cars. The Even with filters that meet the new emission standards, experts say the detrimental effects to the atmosphere caused by these vehicles is which is why friendly electric and hydrogen cars to tackle the fund. To promote the sale of cars, the government announced new plans, including offering discounts on parking and toll gate fees, as well as adding 20 stations throughout the nation by 2020.
When it comes to hydrogen fuel cell vehicles, the most well-known benefit is that it's pollutant-free. The only thing that these cars produce is water, and the water is clean enough to drink.
And a greater environmentally conscious mindset among Koreans. Crowd growth. Yunsin, Arirang News.
Now again, say a question from a friend. If they may ask.
Question what I received that time is
Yeah, if you are using quality spark plug, it means if you generate it with that to generate a emission. Spark plug after maybe 1 month running. So if you are not going to clean it regularly, again it is contribute to the emission. Next.
yes, sir. And the second question, what I received that can running reach damage engines?
It is not advisable
Okay.
because again unburned fuel are emits in the atmosphere.
Okay. Okay, sir. Thank you so much for giving your valuable time on the behalf of our HOD, principal, and our entire department. I would like to thank you for giving your valuable time.
And thank you from my end too. So I interact with the Parul University as you as a bridge. I really enjoyed it. The way you communicate very rapidly because your response is very much early. I have any query, you are solved in no due times. So that is good approach.
Thank you, sir.
And I wish that in future I also get the same opportunity. And
Yeah,
again, I
definitely.
thank the Parul University and the Mechanical Engineering Department to give me a chance to interact with your students. Thank you.
Thank you. Thank you, sir.
Can I leave?
Yes, sir. You can do.
Okay.
Yeah, Jiten, sir. Now, can I leave? Hello. Jiten, sir, are you there?